this lecture, we are going to learn about the filter, map, and zip functions. So let's start the lecture with the filter function. Filter function in Python is a built-in function that allows you to filter elements from an iterable based on a specific condition. It creates a new iterable containing only the elements that satisfy the given condition. The syntax of the filter function is filter function, iterable. The filter function returns the filtered items from a given list and a condition which is passed to filter out the items. Here is how it works. The function parameter is a function that takes in an element from the iterable and returns true or false based on a condition. The iterable parameter is the sequence, like a list, tuple, or set, from which the elements are filtered. The filter function applies the function to each element of the iterable and returns an iterator that contains only the elements for which the function returns true. Here is an example to illustrate the usage of the filter function. In this example, the isEven function checks if a given number is even by performing the modulus operation. The filter function is then used to filter the even numbers from the numbers list using the isEven function. Finally, the filtered result is converted into a list and printed. The filter function is a useful tool when you need to selectively extract elements from an iterable based on certain conditions without explicitly writing a loop. Now let's take one more example to understand the filter function with more depth. We have a list called score, which contains the marks of students in mathematics subject out of 100. Score is equal to 76, 23, 54, 12, 65, 43. Next, we define a function called score_check that takes a single parameter, score. This function checks if the score is greater than 50. If it is, the function returns true. Otherwise, it returns false. The filter function is then used to apply the score check function to each element in the score list. The filter function takes two arguments: the function to be applied, score check, and the iterable to be filtered, score list. The filtered result is stored in the variable students passed. It contains only those elements from the score list that passed the filtering criteria, scores greater than 50. Finally, we iterate through the students passed variable using a for loop and print each value. In the specific example, the output will be 76, 54, 65. That's because these three scores, 76, 54 and 65, are greater than 50 and passed the filtering condition in the score check function. The code demonstrates how the filter function can be used to selectively filter elements from a list based on a specified condition. Next, we have the map function. The map function executes a specified function for each item in an iterable. The item is sent to the function as a parameter. The syntax for map function is map function, iterable. Let's take an example and understand how to use the map function. First, we have a list called numbers that contains some integer values 1, 2, 3, 4, 5. Next, we define a function called square that takes a parameter number. Inside the function, there is a return statement, numbers, ***2. This means the function will take a number as input and return its square, the number multiplied by itself. After that, we use the map function, which applies the square function to each element in the numbers list. The map function takes two arguments: the function to apply, the square, and the iterable to apply it to, that is the numbers. The result is a map object, which is an iterator. To convert the map object into a list, we use the list function and pass the map object as an argument. This creates a new list called squared numbers that contains the squared values of the elements in the numbers list. Finally, we print the squared numbers list using the print function. The output will be 1, 4, 9, 16, 25, which represents the squares of the original numbers in the numbers list. So in summary, this code defines a function to square a number and then applies that function to each element in a list using the map function. The result is a new list that contains the squared values of the original numbers. Let's take one more example to get a grip over the map functions in Python. We again start by creating a list of temperatures in Celsius called Celsius temperatures. In this example, the list contains value 25, 30, 15, 10. Next, we define a function called converter that takes a single parameter temp. Inside the function, we perform the conversion from Celsius to Fahrenheit using the formula. The formula is on your screen. The result is stored in the variable temp. We use the map function to apply the converter function to each element in the Celsius temperatures list. The map function takes two arguments: the function to apply, converter, and the list to apply it to, Celsius temperature. It returns an iterable object. We convert the iterable object returned by map into a new list called Fahrenheit temperatures using the list function. This list contains the Fahrenheit equivalents of the temperatures in Celsius. Finally, we use the print function to display the Fahrenheit temperatures list, which will output the converted temperatures in Fahrenheit. Now, when you run the code, you will see the output 77, 86, 59, 50. This means that the Celsius temperatures 25, 30, 15, 10 have been successfully converted to Fahrenheit as 77, 86, 59, and 50 using the defined converter function and the map function. The code demonstrates the concept of function defining, mapping a function to a list, and using a formula to convert Celsius temperatures to Fahrenheit. Finally, we have the zip functions. The zip function in Python is used to combine multiple iterables like lists, tuples, or strings into a single iterator of tuples. Each tuple contains elements from all the iterables paired together based on their positions. The resulting iterator stops when the shortest input iterable is exhausted. The zip function takes in the iterables as arguments and returns an iterator that generates tuples. Let's take some examples to understand how the zip function works. So we have two lists. The first list contains the names of the students in a class, and the second list contains their ages, respectively. We want to aggregate the corresponding names and the ages of the students into a single tuple and return the list. Let's try doing this. We have two lists defined, names and ages. The names list contains the names of individuals. The ages list contains their corresponding ages. The zip function is used to combine these two lists together. It takes multiple iterables as arguments and returns an iterator of tuples, where each tuple contains elements from the input iterables, paired together based on their positions. In this case, we are zipping the names and ages list together using zip names, ages. The result of the zip function is assigned to the combined variable. It creates an iterator that pairs the names and ages together. We then use a for loop to iterate over the combined iterator. This allows us to access each pair of name and age. Within the loop, we have two variables, name and age. These variables are used to store the current name and age values from the iterator. Finally, we print each name and age pair using the print function. The output of the code will be Alice 25, Bob 30, Charlie 35. The code shows how to combine two lists and iterate over the combined pairs of values using the zip function. It's a way to associate corresponding elements from multiple lists and then processing them together. Let's now take an example of unzipping tuples. We start with a list called students that contains tuples representing each student's name and age. You can see it on your screen. This assigns the list of tuples to the variable students. Each tuple represents a student's name and age. For example, the first tuple, Alice, 25, represents a student named Alice with an age of 25. And here is the next line of code. This uses the zip function to separate the names and ages into two separate tuples. The zip students part of the code uses the asterisk operator to unpack the students list. This means that instead of passing the entire list as an argument to zip, each element of the list, that is each tuple, is passed as a separate argument. This effectively transposes the list of tuples, resulting in two tuples, one containing all the names and another containing all the ages. The result of the zip students operation is then assigned to two separate variables, names and ages. Each variable now holds a tuple with the corresponding data. Finally, we use the print function to display the names and ages respectively. Print names will output Alice, Bob, Charlie. Print ages will output 25, 30, 35. The code essentially takes a list of tuples representing students' names and ages, and by using the zip function with the asterisk operator, it separates the names and ages into two separate tuples. This allows us to access and work with the names and ages individually. And with this, we have come to the end, where we learned about how to use filter, map, and zip functions and how they can be useful to us in the context of data manipulation.